All right, so in this video, we want to talk about solving linear equations. And I say the full story, and by what I mean by that is that we'll be able to solve any linear equation, hopefully, after this lesson. So far, we've been able to solve equations that are pretty basic, like x plus 3 is equal to 19, or 3 times x is equal to 19, right? Like that. And so these would just be very basic ones that require one step. We've also talked about some basic simplifying that you need to do first, where we may have had something like 5x minus 3x. 3x is equal to 18, something like that. So you might want to just real quickly pause and refresh yourself about how you would solve all three of those. Um, if you did do that, hopefully you did. Here's one last chance to pause. But this first one, you would end up with x is equal to 16. This second one, you would end up with x is equal to 19 over 3. And then this third one, you would end up with x is equal to 9. Now make sure, too, to go through the steps about how you actually solve those. Try to avoid skipping too much and so on, okay? And so what we're getting into, though, are some more involved ones, all right? Now, one starts out pretty basic, but I could have something like 2x plus 3 is equal to 19. And this kind of problem, it's a very common type of equation to come up in that with applications. But what it's going to do is it's going to require combining these two steps right here, and before we can actually solve it. Okay, but we'll get into much more complicated ones. So we might have something like 3 times 2x plus 1 minus 4 is equal to 5x plus 4, like that. Okay, and that requires doing quite a bit of work before we could actually get to the solution. Okay, and again, my basic advice is try to follow along how I do things and notice the mechanics. Go through the mechanics and take it one step at a time whenever you solve, and you can become an effective equation solver. Now, I started to go ahead and start talking about the process and lay out the steps, but I thought it'd be best just to look at some examples to see the process so you can understand what I'm talking about in the next slide where I actually lay out the process. So as you watch this, just watch. Don't feel like you have to understand everything because we're going to go through this a little bit more carefully in a moment. Okay, but anyway, let's look at this first example, a little bit more complicated than we've seen. All right, and so remember that the first thing you want to try to do is simplify each side. So you treat each side like it's its own algebra simplifying problem. And remember that simplifying means to clear parentheses and collect like terms. All right, so first we look at our left side. There's no parentheses, and notice these aren't like terms, and so I can't collect them. So this first, the left side is simplified. Same thing over here on the right. There's no parentheses, and these aren't like terms, and so they don't collect. So in this one, we don't have any simplifying to do first, but in general, in a lot of cases, we will, namely with this second example that we'll talk about in a minute. Okay, so the general thing is once each side is simplified, what you want to do is move all the terms that have the variable in it to one side of the equation and all the terms that have just numbers in them to the other side of the equation. So remember the things that may constitute the word term is the things that are separated by additions and subtractions. So here's one term, here's another term, here's another term, and here's another term. So I want to move all the terms that have the variable in it to one side. So here I have the two terms that have the variables in it are the 5x and the 3x. Typically, we move the variables over to the left side, and you can. Sometimes there's an advantage to moving variables to the right that we'll point out later, but you don't ever have to. If you always want to just move your variables to the left to make it easier on you, you can. Just you're going to have to deal with some negatives sometimes, so hopefully you're just comfortable with that. So the idea is I want to move this 3x over here to this side, okay? And so I want to move this entire term over, so I want to get rid of this. Well, notice that this is really a positive 3x, a plus 3x, right? And since I want to move it over, like I said, so since I want to move it over, I would actually subtract this 3x on both sides. Okay, and so I would subtract 3x on both sides. Okay, like that. And so 5x minus 3x is 2x. Now, some of you will get comfortable enough where you can do these next two steps on the same line. But for now, let's do just one thing at a time. and then equals 3x minus 3x is 0, so that disappears, and all I have left over here is my 8. Okay, so notice that on my left side I just have my variable in it, and so that means that I want to move my numbers over to the right side. So I want to move this minus 4 over, and just remember we use the opposite operation to do that. Here I'm subtracting 4, so then I would want to add 4 to both sides. Okay, like that. So now on my left I have 2x. Here I have minus 4 plus 4. That's 0, so it'll disappear right here. But then over on my right side I have 12. Okay, like that. And then let me separate out these problems just to be safe. All right, and then so now I'm ready to isolate my variable. Okay, once you have just a variable on the left side and a number over on the right side, then you're ready to isolate your variable. So what's the deal? I need to get this 2 separated from the x. And so what is that 2 doing? It's multiplying the x. And so what's the opposite of multiplying? It's dividing. Like that. And so we see I ran out of space, but I would keep going down if I were doing homework. And so these 2's cancel each other. So all I'm left with on my left side is x, and then equals 12 over 2. That's 12 divided by 2, which is 6. Okay. Now, just to save time, because I'm going to go through the process and do a lot of examples, but we should check that. But once you're sure that that answer is correct, that's whenever you answer it. Circle it. And so remember to circle answers, too, so that it's easy to see where they're at. Okay. So now there's a couple key things I want to go ahead and point out on this example right here. Is notice on these first 2 lines, or these first 2 things that I did, I moved entire terms to the other side. I took this entire term 3x and I moved it over to the other side by subtracting. Okay, same thing here. Minus 4 is an entire term, and so I moved it over by adding. Okay, and so you're going to see on the next slide, whenever I explain the process, I'm going to talk about whenever you move an entire term over, we'll always use addition or subtraction just for that. But then notice once I got to this line, the 2x equals 12, I wasn't moving an entire term. 2x is its own term, okay? I wasn't moving that entire term over. I was just pulling the coefficient off of the variable. And in that case, I used division, okay? And so, like I say, I'm just trying to do this to let you see some vocabulary you're going to see on the next slide. But whenever we move entire terms over, we'll always use addition and subtraction. Addition or subtraction, but whenever we just peel numbers off of a term, then we'll always use we'll usually use division. Sometimes we'll use multiplication. Okay, so now this problem, example 2, will be pretty much like the last one once we get things simplified. But we have some simplifying here. Notice that I have these parentheses, and then also once I clear my parentheses, I'll have some like terms. And same thing over here on the right side. So the first thing you do is you just treat the left side like it's its own simplification problem. Okay, so the first thing I want to do is distribute that 5. And so I'm going to get 5x plus 5 times 4 is 20. Now notice I didn't do anything to that 1, so it just stays there, plus 1. Okay, and if you want to treat it like it's on 2 separate problems, the left and the right, then go ahead and do this. Notice that 20 and 1 are like terms. And so my left side becomes 5x plus 21. Okay, then I come over and I do the same thing on the right. Sometimes you don't have as many things to do on one side as the other. Sometimes one side will need to be simplified, the other side won't need to be simplified at all. Okay, but anyway, over here on the right, when I distribute that 2, I get 2x minus 2 times 1 is 2. And then I didn't do anything with the minus 4, so it's still there. And then notice I have these 2 like terms. Minus 2 and minus 4, that's minus 6. So we get 2x minus 6. Okay, so notice, too, if you're having trouble understanding that simplified idea, notice that the form of this one, we had a variable term plus or minus some number equals a variable term plus or minus some number. Okay, I have the exact same form right here. Okay, and so that's how you know you have things simplified. Now be aware, sometimes you won't always have both of these, okay? Sometimes the right side will just be a number or just have the variable in it. Same thing on the left side. Okay, anyway, so now we proceed as we did before. First thing I want to do is get my variable terms over on the left, okay? And so I want to move this 2x over here. What am I doing? I have a plus 2x, so to move it over, I would subtract 2x from both sides. Okay, with that, and then 5x minus 2x is 3x plus 21 equals, these two things subtract out, so they give me 0, so all I have over on my right side is minus 6. Okay, and then, so now I have my variable term over on the left side, so I need to move the numbers over to the right side. And here I have a plus 21. How do I move that over? I subtract 21 from both sides. Okay, with that, and so then I have 3x plus 21 minus 21 is 0, so that goes away. And then negative 6 minus 21 is negative 27. All right, like that. So now I only have a variable term over on the left side, so I'm ready to isolate the x. X is being multiplied by 3, so to cancel that 3, I would divide by it. All right, like that. Here they cancel, and so over on my left side I get x. On my right side I have negative 27 divided by 3, so remember how that works. I just do 27 divided by 3, which is 9, but since I have a negative divided by a positive, the answer comes out to be a negative. Okay, like that. And again, we should be checking, and I'll talk about checking even these complicated ones with our examples. The main thing is I want you to see the process. And the process, the full process, again, you won't necessarily always need all of these steps in every problem, but the full process is illustrated here with our second example. First thing you do is simplify each side, okay? Then you move entire terms over by either adding or subtracting on both sides, all right? And then once you have just your variable over on the left side, you'll either multiply or divide to get rid of that number, and then you'll get to your answer. All right, so yeah, we basically just laid out all that. So the basic steps to solving a linear equation is you just simplify each side, okay, and these are the steps involved in simplifying. If there's any parentheses, you clear them with distribution, and then you collect any like terms, all right? And then we move all the numbers to one side of the equation and all variables to the other side of the equation. And remember, whenever you're doing that, you're moving entire terms, so you'll always use addition or subtraction, okay? And then once you've done that, then you'll just isolate the variable. You always isolate using multiplication or division. And then again, just remember that idea here is that in the bigger picture, you're using the opposite operation whenever you're moving things. Okay, and that helps you decide, a lot of people will have something like 3x equals 27. We had negative 27 in the last example, right? And they'll accidentally subtract or something like that. And so whenever you get to that step and you're wondering, just say what operation is keeping that x from getting isolated. Well, there's a times right there. And so the opposite operation is dividing. So, you can use the division sign. It's just we very rarely use it in math. So you could write it that way if it helps you remember the division easier. But like we've been doing in our examples, we got to the point where we recognized that fraction part was a division, and so we usually just write over 3. And that also it has an advantage that whenever your answer is a fraction, then it's easier to recognize it that way. Okay, so we're going to do a lot of examples in this video, but that are going to progressively get harder. But right now we just want to solve the equation. So these are 3 pretty basic ones. So if you want to, feel free to pause and see if you can get the answers. And then, but I'm going to proceed otherwise. Okay, so on our first one, so again, hopefully you're taking notes, and from that previous slide, make sure to write down those steps and have them with you, especially if you're learning this or relearning this, and just follow those steps, okay, in order. So anyway, on our first one, we have 5x plus 4 is equal to 17. That's pretty basic, but a lot of application problems / word problems end up solve an equation of this form right here. Okay, so anyway, we try to simplify each side. There's no parentheses on either side, and if you look on the left side, these aren't like terms, and this only has one term in it, so there's no like terms to do there. All right, so both sides are simplified. So see, we don't always have to do all of the steps. Okay, so the next thing we do is we want to start moving variables to one side and numbers to the other side. Now notice this equation only has one variable term, and it's on the left side, so I want to have all my variables over on the left side, and all I have to do is move the numbers over to the right side. So I want to move numbers over here to the right, but I have a plus 4 over on the left, so I want to move it over. And so notice that I have a plus 4. What's the opposite operation of that? Subtracting 4. Okay, like that. All right, and so I subtract 4 from both sides. So over on my left, I have 5x. Plus 4 and minus 4 make 0, so that goes away. And then I get 13. All right, so now I have all my variables on one side and my numbers on another side, so I'm ready to isolate. Isolate means to get this x all by itself. What's the problem? It's being multiplied by 5. So what's the opposite operation of that? Dividing by 5. Okay, and so I end up with x is equal to 13 over 5. All right, I'm not doing a good job of leaving myself enough room. Hopefully that's not confusing to you. Now, one thing here, fractions are just numbers, okay? And so don't let it throw you if you get a fraction as an answer. First of all, if it's not clear if you should keep that improper or mixed, I always say just to use both, all right? And so if you want to, that would be what, 2 3/5, okay? Now, the key thing is don't let it throw you if you get a fraction of an answer, but make sure that it's correct. Always do, whether or not it's a fraction or not, by checking it. Okay, and so remember, here's our original equation, 5x plus 4. We'll start to write 14. 5x plus 4 is equal to 17. And I think that x is equal to 13 over 5. So I'm going to plug that in right here. We're wondering if that left side is equal to 17. Okay, and so right here I have 5 over 1 times 13 over 5. And so those 5's cancel each other. And so I just get 13 plus 4. And we're still wondering if that equals 17. You can probably see that. Okay, now remember too, I just want you in the habit of checking. So to check this, you could just as easily, just on your calculator, type it in just like it's written. So you'll type in 5 times 13 divided by 5 plus 4. Hit enter, and your calculator should display 17, and that's the way you know it checks. Okay, so I'd rather you just get in the habit of checking, but I don't want you getting bogged down either, taking just as much time to do a check as you do to work a problem. Okay, I just want you to try to have a little bit of pride and try to get in the habit of actually checking yourself. Okay, so now on our second example, again, there's no parentheses on either side, and there's no like terms on either side. Okay, and so we're just starting to practice going through the process, and so we're starting pretty basic, but so we're ready to start solving now. And the first step in solving is to move all the terms with the variable to one side and all the terms that are just numbers to the other side. All right, so I'm going to move my variables over to the left again. All right, there are, in this equation, some people would say that you should move them to the right. I'll explain why in a minute, though. So let's just follow our normal process first so you can see why. So I want to move that 7n over to the left side. So I'm going to, since it's being added or there's a hidden plus in front of it, I would subtract 7n from both sides. Okay, like that. And so be careful here. We got 3 minus 7. That's actually negative 4n. Okay, we haven't done anything to that plus 5 yet. All right, equals this 7n and minus 7n actually subtract each other out. So all I have left over on the right side is minus 3. Okay, so I have my variables over on the left. So I want to move that 5 over to the right using the opposite operation. So I'm going to subtract 5 from both sides. All right, like that. And so I get negative 4n is equal to negative 3 minus 5 is negative 8. All right, so now I have variables on one side, numbers on the other, And so I just need to get that coefficient off my variable. That negative 4 is being multiplied by n, so I would divide both sides by negative 4 with that. Okay, and so to get n here, the negative 4's cancel. I have n, and I have negative 8 divided by 4. Just remember to do 8 divided by 4, which is 2. And then I have a negative divided by a negative, so our answer is positive 2. Okay, and again, to check this, okay, here's our equation. 3n plus 5 is equal to 7n minus 3. Okay, and I think n is equal to 2, so I'm going to plug it in on both sides of that equation. Now, one thing to realize about your if you're going to use your calculator to check this, your calculator doesn't take equations typed in, so you can't type this entire thing in on your calculator. What you do is you, just like you were doing by hand, you would compute this entire side, and if you're doing it with your calculator, you would hit enter, and then you would type in this entire side, and then hit enter, and the two results, it should give you the same number on both sides. Okay, so anyway, if you're this one's quick and pretty straightforward to do by hand too. On my left side, sorry, we're wondering if these two sides are equal right now. So on my left side, I have 6 plus 5, which is 11, and then on my right side, I have 14 minus 3, and that does equal 11 as well. Okay, so make sure you realize where the answer is too. This is our answer. All right, some people get confused and end up saying this is the answer. This is just the number that shows us that the two sides are equal, but our solution is actually n is equal to 2. Okay. Oh, I just realized I did something against. I got busy talking about checking and getting to the next one. So yeah, try to get in the habit of circling your answers. Okay. Now on the third one, there's a little bit more work to do because notice over on my left side I have those parentheses. All right. So at the very least, I'm going to have to clear parentheses. Now, if you look over on the right side, there's no parentheses, and these aren't like terms. And so there's not any simplifying to do on the right. So you don't always have to simplify both sides. Okay? So the first thing I want to do is just simplify the left side. Okay? So I distribute that 4, and I get 4y plus 4 times 2 is 8. Okay? Now, important about this, we are just working with the left side. Okay? Well, let me point it out even with that last thing. So we are just working with the left side. So anything that you don't work with going from line to line, you just rewrite it. Okay? One place where the students go astray is they'll just start writing pieces, and then once they need to get back to the equation, they've lost it, and they can't find where they left off, and they end up getting confused about what they're actually trying to do. So anything you work, going from line to line, anything you work with, then of course you change it into what it's going to be. But anything you don't work with, see, you just rewrite it like that. Okay? Now, we're not done simplifying this left side because notice I have these two y terms, and so I need to collect them. I have 4y minus 2y. 4 minus 2 is 2, so I get 2y plus 8 is equal to 3y minus 11. Okay? So just following our normal format, we'll move the variables over to the left side. So I need to move this 3y here over to the left side using the opposite operation. So I'm going to subtract 3y from both sides. Like that. Okay. And now be careful on this. 2y minus 3y. 2 minus 3 is negative 1. Like that. And writing that negative 1 will help you avoid a common error that people make. So we've got 3y minus 3y is 0, but and so all we have is minus 11 over on the right side. Be careful too. A very common error for people to make is to just say 11 right here. So remember, whenever you got that negative in front, make sure to carry it down to the next line. Okay. So my variable terms are over on my left. So now I want to move the numbers over to the right, and so I get minus 8 and minus 8. Okay, like that. So on my left side, I have negative 1y is equal to negative 11 minus 8. That's negative 19. Now, again, if anytime you're doing homework and you have room, just keep going down. I just ran out of room. And so here's where we left off. Like that. And then, see, if you write that minus 1, some people will just write that as minus y. But then to isolate y, they don't realize that they need to divide by a negative 1. right here. But if you have it written like we have it written right here, then it's really clear. Y is not isolated yet. Isolated means that the variable's all by itself, but I have this -1 I'm being multiplied by, so I need to divide both sides by -1. So over on the left side, they cancel. I get y is equal to 19 divided by 1 is 19, and then I have a negative divided by a negative. So my solution is 19. All right, so now I'm going to show you how to check this with your calculator. You can do this by hand. I'm not discouraging anybody, but I haven't really showed you how to do that. So we're going to just do the check on our calculator. Okay, and the idea is that the left side should equal the right side of my original equation if I plug in y equal to 19. Okay, so we're ready to look at this. Now remember, the key thing here is that I think y equals 19 is my solution, and I'm plugging it into this equation here, okay? And so the key thing is, though, on our calculator we can't type in an equation. So first I'll want to plug it into my left side, and then I'll want to plug it into my right side. Okay, and remember, you just type it in just like it's written. So 4 parentheses, don't forget those parentheses. And then we think that y is equal to 19. So my calculator's a little jumpy today. So we have 4 times 19 plus 2. I'm just filling in 19 for y. And then minus 2. This is one place where you can't, you got to remember that that's a times. But if I typed just 2 with 19 next to it, it would think that I'm saying 219. So we get 2 times 19. All right, so there's my left side. It comes out to be 46. And so if I plug 19 into my right side, I should get 46 as well. So my right side is 3 times y, so that's 19, and then minus 11. Like that. Let's hope it equals 46. Oh, yay, it does, okay? And so now we know that we're correct, and that's a good time to circle your answer. So my left side was equal to 46, and my right side was equal to 46. So I got the same thing on both sides. Now there's two things I want to show you with one of the previous examples. These are advanced though, so if you're prone to errors, I advise taking it more step by step. So you can just forward to the next slide where I start with more examples. Okay, and so this isn't something you need to do, but some people uh, can do things. So the first one is you can do all the moves over. Okay, all the moves over in one step. Okay, it can save you some time, but it gets a little bit more cluttered that way. All right, and so it's just a matter of how you look at it. So first, let's look at it where we're moving the variables over to the left side. So remember what the idea was. I needed to subtract that 7 in from both sides. Okay, but some people can also see the next thing they're going to do is move this plus 5 over to the right side. So instead of doing it in 2 steps, they'll do it all at once. Okay, like that. And then you just look at everything carefully here. You got 3n minus 7n. That's -4n. Okay, and then we have 5 plus -5, or 5 minus 5, sorry. And so that's 0, so that part goes away. And then we get equals. And then again, we have 7n minus 7n. That's going to give me 0, so that part will go away. And then we got -3 minus 5, which is -8. Okay? And then, so then you're basically skipping a step, but the step you're using to skip is a little bit more cluttered up. Okay? And so it's just a matter of how you see it. And then the other thing to point out with this example is sometimes we want to move things to the right, move the variable to the right side. Okay, and this example illustrates why. And it's just, if you can deal with negatives, this isn't a big deal. Okay, but some people don't like or they're prone to errors whenever they have to get rid of a negative number, and so they don't like getting this negative number on the left side. So what they do is they start out at the beginning. Okay, 3n plus 5. Now again, sometimes this is after you've simplified and problems where you had to simplify, but they can look at it, some people can look at it and say, well, if I subtract the 7n, I'm going to end up with a negative over on the left side like we did. Okay, but if I did just the opposite, if I moved the variables over to the right side, then I would subtract 3n on both sides, and then this would end up being positive. Okay, so some people will do that. It's totally up to you, like I say. But let me show you how that would progress if you did choose to do that. So here I would subtract 3 in from both sides to get my variables over on the right side. Okay, and you could combine both of these techniques and do everything at once. But just to illustrate a little bit more carefully here and to point something out, so we got 5 is equal to 4n minus 3. So see, now I have a positive number. Now the key thing is, if you're going to do that, realize you moved your variables over to the right side, so I need to move my numbers over to the left side this time. So I got to move that minus 3 over. Its opposite operation is adding 3. Like that. And so we end up with 8 is equal to 4n, all right? And then whenever I go, now I need to isolate the variable, and so there's a 4 on my variable being multiplied by my variable, and so I want to divide by that. And then don't let it throw you, just let the math present itself. Over on my left, I have 8 divided by 4, which is 2, and then is equal to, these 4's cancel, and so I have n. All right, so don't let it throw you if it you know, the saying, remember, let's just think about how to translate this into words. Remember, this means is. So up here, this is saying n is 2. That's the way we would normally say it in English. All this is saying is 2 is n. All right, it's saying the same thing. It's just a little bit, sounds a little bit backwards. Okay, and so, and then again, if that throws you too, if you do solve an equation and end up with something that looks like this, and if it bothers you writing it that way, then just rewrite it the other way. Okay, so those are just some advanced moves to point out that some people can grasp, but like I say, don't feel like you have to. Okay, so let's start looking at some more complicated examples. I'm just going to write one at a time just in case I run out of room, so I don't have to keep doing that. Okay, so here's our first one. On any of these, just go ahead and pause at the beginning if you want to try it and see if you can get it right. All right, but anyway, so on this one, we look to see if we can simplify either side. My left side's 15 minus 2v. There's no parentheses, and these aren't like terms. So there's nothing I can do with my left side. All right, and so now notice that I have parentheses over on my right side. So I need to distribute. What do I need to distribute right here? I need to distribute negative 3 over these two terms right here. Okay, so right now that 5 doesn't have anything to do with the distribution, so I just write the 5. And now I want to distribute negative 3 over these two terms right here. Okay, so I got negative 3 times v, that's minus 3v. And then I have negative 3 times 4, that's negative 12. Okay, like that. And then notice over on my left side, or on my right side, sorry, I have these two like terms right here. So I need to collect those first. So I have 15 minus 2v here equals, and so I have 5 minus 12, that's negative 7. All right, so you could write negative 7 minus 3v. Remember, if you don't do anything with the term, then you just rewrite it. Okay, so some of you may have preferred to write the negative 3v out front. It doesn't matter. Okay, so just over here on the right side. I'm just going to keep it the way I've written it and finish from there. All right, so it's up to you how you want to proceed here. And so I'm just going to, some of you may have skipped over that last slide. So I'm going to move my v's over to the right side. It's actually more advantageous to move them. I think I just said the right side. I meant the left side. Okay, so I want to move my v terms over to my left side here. And so I got to move this minus 3v using the opposite operation. So I need to add 3v to both sides. Like I say, you folks that watched the previous slide and you're comfortable with it, you could do this all in one step. Because I told some people not to, I'm just going to stick with my breaking it into 2 steps. So I have 15, and then I have minus 2 plus 3. That's plus 1, so I have plus 1v. Or you could just write that as plus v if you realize that. And then over on my right side, all I have left is minus 7. Okay, like that. And so I probably would take, if I did write 1v, I'd probably take an extra line just to get rid of it. And what that'll help you do is, see, we only have one line left here. So now my variables are over on the left, so I need to move my numbers to the right. So I need to move this 15 over. That's a plus in front of that 15, so I would want to subtract 15 from both sides. Okay, 15 minus 15 is 0, so all I have over on the left, well, let me show you something here. So some of you might realize that we just have v on the left. on the left. And then negative 7 minus 15 is negative 22. Now, if you didn't see that, just think about what this really is. This is 0 right here, though. So we have 0 and then plus v. Okay? But what is 0 plus anything? It's just itself. And so then over on my left side, I just have v is equal to negative 22. Okay? Like that. And so now for the check, again, our equation is 15 minus 2v is equal to 5 minus 3 times v plus 2. V plus 4, oh my goodness. Okay, like that. This is one, unless you're very good at arithmetic, I would probably advise checking this with your calculator. Okay, so as far as on your left side, that's going to be 15 minus 2 times negative 22. Okay, and over on my right side, I'm going to have 5 minus 3 parentheses negative 22 plus 4. Now remember, your calculator, if you're going to do, if you're using your calculator is really picky about subtraction and negative. I was going to have you just check this, and I was going to do it without a video, but let me go ahead and show you this just to point that out. Okay, so remember over on my left, I got to do 15 minus 2 times negative 22. So remember on your calculator, this is the subtraction key and this is the negative key. All right, and I'll show you that it gives you either an error or a different result if you use the wrong keys. So 15 minus 2 times, and then I hit negative 22, like that. Okay, so over on my left side, I actually get 59. Okay, like that. But let's see. First of all, look at this. If I type 15 and I accidentally hit the negative key, okay, times negative 22, like that. See, I get an error because it doesn't know what the heck I'm even trying to type. And then if I accidentally didn't use the negative key right here, if I use the subtraction key, it's going to give me something very different than what I should be getting. So 15 minus 2 times minus 22, I'm going to get an error there too. All right, so see, you just got to be careful. If I didn't use that times symbol there, then it would end up subtracting. It would give us something that was incorrect, so we would think we were wrong whenever we were actually right. Okay, so we get 59 on the left side, and now we just need to type in 5 minus, I'm checking the right side now, so I'm checking over here now, 5 minus 3 parentheses, make sure to use that negative key, negative 22 plus 4, close parentheses, hit enter. There's 59 as well. So yeah, we get that 59 on both sides, and so we're good to go, and so that means that v equals negative, that means that v equals negative 22 is our answer to that problem. Now, one thing to point out, you can see things get complicated, and so what you want to do is take your time and go step by step. The more you skip, the more prone you are to making an error. And see, say that you skipped too much, you went down to here, but you made an error. Then look at all this work that's after it, and it's all wasted because you had an error in here. So just try to take it one step at a time. Even if you take shortcuts, just whatever you do, go one step at a time. Hopefully you even check yourself each step. I know that's not always easy to do once you're going, but that's key in math, but and especially with these complicated kind of equations. One step at a time, not try to skip too much, and you can be successful. Okay, so let's look at this one. As always, pause if you want to try it first. But we have, remember we want to start by simplifying each side, and we have parentheses on both sides here. So that's how we would start. On the left side, I would distribute this 7, so I have 14y, 7 times 2, and then plus 7 times 1 is 7. And so remember, this minus 1 didn't have anything to do with the distribution, so I just rewrite it. Okay, and then equals, over here I need to distribute that 3 over these two terms. We have 3 times 4y, that's 12y, and then 3 times 2 is plus 6. Okay, like that. All right, now over on my left side, I'm still not done simplifying because I got this 7 minus 1, which is pretty easy to clean up real quickly. See, and you still write it a line at a time. What that'll help with, too, is if you do check and you find that you have a mistake, it's easier to find where you made the mistake, where you might not have to rework the entire problem. Okay, so now I need to move my variables to one side, so I'm going to move my y's over to the left side. So I want to move the y's over to the left side. This is a plus 12, and so the opposite operation is subtracting 12y. Okay, and so 14y minus 12y is 2y. At plus 6, we didn't do anything with. We have 12y minus 12y, that's 0, so all I have left over on my right side is 6. So my variables are on the left, so I want to move my numbers over to the right. And so here I have a plus 6, the opposite operation is minus 6. That. And so on my left I have 2y equals 6 minus 6 is 0. Did we make a mistake or something? And the answer is no, probably not. I'll tell you in a minute how we know we had an error or not. But remember, 0 is just a number, okay? And so don't let it throw you. Just keep following the same steps. How do you isolate the y now? You have 2 times y. The opposite operation is dividing by y, so we do divided by 2. The 2's over here cancel, and so I have y equals 0 divided by 2. Now remember, there's these things about 0 that some people have trouble remembering. What you can do, if you can't remember if this is 0 or undefined or whatever you think it is, plug it in on your calculator, and then, after you do it a few times, you'll start remembering too. So you can do 0 divided by 2 on your calculator, and that'll give you 0. All right, so 0 divided by any number is 0. So y equals 0 looks like it's our solution. By the way, if where you might be getting confused is sometimes you get an undefined whenever you do that. If you typed in 2 divided by 0 on your calculator, it's going to give you an error. And so that's the case where you say undefined. Okay, so here it looks like our answer is 0. Now we still need to check it, and that's what I was getting at a minute ago. Don't worry about if a weird number shows up here in the middle of your work. Just keep going, okay? And then the way you know whether or not you made a mistake or not somewhere along the line is whether or not this thing checks, okay? And so we do our check here, and so we have 7 times 2 times 0 plus 1 minus 1. I just plugged 0 in to the left side of my original equation if I move too fast on you. Okay, and then we're wondering if that equals, we plug 0 into the right side, so we have 3 times 4 times 0 plus 2. Now, right now, we're wondering if these are equal. Okay, once you have numbers plugged into an algebraic expression, all you're doing is calculating from there, following an order of operations. If you're doing it by hand, you can type, just like with that last example, you can type in on your calculator. So we do parentheses first, that's 0 plus 1 minus 1. I'm just going to calculate my whole left side first. Then I keep going with my parentheses, so that's 7 times 1 minus 1. And then I have 7 times 1, which is 7 minus 1. So on my left side, I get 6. Okay? And then I'm wondering on my right side, I do the parentheses first. I multiply first in the parentheses, so I have 3 times 0 plus 2. We're still wondering right now. And then 3 times 0 plus 2 is 2. Okay, but 3 times 2 is 6. So notice the left side does equal the right side, so that does check. And that means that y equals 0 is the solution. All right, let's just do one more example. This is getting pretty long. But this is a really complicated one. So this is a good illustration of taking step by step, realizing a lot of the layered algebra that we've seen too. And I just haven't been pointing that out enough. Notice how much we use arithmetic, how much we use the simplifying idea and distribution, and so on like that. And so everything is layered, and we just build up a step at a time. But anyway, now for this equation. All right, so notice we have more than one set of parentheses on each side. So we have double distributions to do. So on my left side, first I distribute that 10. Okay, so I end up with 10z. 10 times 4 is 40. Remember, the most common error with distribution is forgetting to distribute on that last number there. So some people actually accidentally write 10z plus 10. All right, now on the second one, I have, what do I have to distribute? There's a negative on that too. And so I distribute negative 4. And so I end up with minus 4z. And then I have negative 4 times negative 2. That's plus 8. All right. Now you can take it a step at a time. You could have -4 times -2. So feel free to write out your distribution steps too. All right. And then equals, and then now I distribute this 3. And so I have 3z minus 3, like that. And then I need to distribute this 2. And so I have plus 2z minus 6. 2 times 3 is 6. All right. So hopefully I'm not too cluttered up in there where you can see what's going on. But now on each side I have like terms to collect. Okay. So I don't know why I wrote that. Okay. So here I have 10z minus 4z. That's 6z. Started to write x, 6z. And then I have 40 plus 8. That's 48. Okay. So notice things are starting to look pretty simple now. It's in just 2 lines from that really complicated expression. And then over on my right side, I have 3z plus 2z. That's 5z. And then I also have -3 minus 6. And so that's -9. All right. Look how simple now this is looking. Now I need to get my variables over on the left side. So I want to move that 5z over right here to the left side, so I'd want to subtract it from both sides. -5z minus 5z. 6z minus 5z is just 1z, plus 48 is equal to -9. Okay, like that. Now remember, 1 in front of a variable is just a variable, so I really just have z plus 48 is equal to -9. All right, all I got to do now is just move that 48 over. And so since it's a plus 48, I subtract it, -48, like that. And so what do I end up with? Z is equal to -9 minus 48 is -57. Now for checking this one, I'd probably advise using the calculator because that calculation is going to be pretty tough. I mean, I'm sure several of you could do it by hand. It just might take you a while. So let me get that up. Okay, so here's my calculator. Remember that we got that z is equal to -57, right? Like that. And what do I want to plug that into? I want to plug it into my original equation. So I want to plug it in here on my left side and then plug it in here on my right side. And hopefully they come out to be the same. So the first thing I'm going to do is plug it in on my left side. So I have 10 parentheses -57 plus 4, like that. And then -4, and remember that's the advantage of these calculators, is that you can type in an entire expression, oops, and then -57 minus 2. Just be careful about the difference between the negative and the subtraction key. All right, if you do type something in and you get an error, that's always the first place to look. Okay, so my left side is -294. All right, and so on my left side I get -294. So if I did all my work correctly, if I plug that in on my right side, I'm going to get the same number. Okay, and so now I plug in over on my right, so I have 3 times -57 minus 1, close parentheses, and then plus 2 times -57 minus 3. Do you see what I'm doing? I'm plugging -57 into my right side right here. Okay, so drum roll please. Oops. And what do we get? We get -294, what we were trying to get. Okay, so that means that this equation, that number checks into that equation. And this is another one that's a weird number, -57. Why are we getting that as a solution? I don't know why we're getting that as a solution, but at least I know I'm correct. All right, so I'm going to leave that there. Hopefully that's enough where you can be successful with this. And the main thing, remember, take it a step at a time. All right, I hope that helps, and best of luck.